Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about linear functions or linear equations. So linear functions are functions where all of the terms have a degree less than or equal to 1. In simple terms, that means that we're not going to encounter powers higher than 1 with our terms. And we're not going to encounter terms that have multiplication of different variables, because the degree of those terms will be the sum of all of those exponents. So if we had x times y, that would be degree 2. So this is an example of a linear function. So the degree of every term in the equation or the function will be less than or equal to 1. When you draw the graph of a linear function, the graph will be a straight line. And because it's a straight line, the slope of it will be constant. So if we took a look at this example, the graph would look something similar to this. And I can rearrange this in there's different forms to write linear functions. I would prefer to rearrange this to isolate the y. So I'm going to add a y to both sides, subtract a 4, and I will get y equals 3x minus 4. This is going to be something I'll talk about when I talk about the different forms of expressing the linear equation, but that's one I prefer. It gives me a lot of information, as you're going to see shortly. Let's take a look at how to find slope of a straight line. If we were to take an arbitrary line and put two arbitrary points on that line, I'm going to define those points by these ordered pairs. These are called ordered pairs, and they consist of two numbers or two variables. The first value represents the independent coordinate, which in this case is an x, so the x coordinate. The second variable represents the dependent variable, which in this case is y. And I'm going to call this point x1, y1. I'm going to call this point x2, y2. And whenever you're finding the slope is defined as rise over run. So rise is vertical distance. It would be the distance from this y value to this y value. That's going to be the rise. Divided by the run represents the horizontal distance. So from this x value to this x value, that's called run. Another way that you will see slope expressed is delta y over delta x. Delta is a symbol used for change, so that's simply saying the change in y over the change in x. And specifically, the way that we can define the change in y with these 2 points is one y value minus the other y value, so y2 minus y1, divided by the difference in the x values. If I chose this y value and subtracted this y value, then I have to choose this x value and subtract this x value. So just be careful that you're consistent with the order. If I put actual numbers in for my points, we can fairly easily find the slope. A letter that's used to represent slope is the letter M. So I will use M to represent slope. It's just convention. So if I wanted to find the slope of this line, I would say the slope is equal to the rise, which is y2 minus y1, so 5 minus 2, divided by x2 minus x1, so in this case it will be 4 minus 1, so 3 divided by 3, which we can simplify to a 1. So what that's saying is that if I thought of that as a fraction, for every rise of 1 unit, there will be a corresponding run of 1 unit. Or for every rise of 3 units, there will be a corresponding run of 3 units. So understand what slope means and know how to find it. We can just simplify that. Let's take a look at certain types of lines and what their slopes are. Let's take a look at these 4 examples, and I just want to point out something about the slopes of these particular lines. We already did this example where we found the slope was the difference in the y values, which was 3. That's the rise, divided by the difference in the x values, which was 3. So we have a slope of 1. What I want you to understand is that it's a positive slope, and whenever you have a positive slope, your line will go up as you move left to right, or in other words, the y values will increase as you go left to right. Unlike this example, where the line is going down as we move left to right, and I'll show you what the slope looks like. So we took the difference in the y values, so 3 minus a negative 2, divided by negative 3 minus 4. 3 minus a negative 2 is 3 plus 2, so that will be 5. Negative 3 minus 4 is negative 7. And I'm going to take the negative out of the denominator and write it out front, either in the numerator or just out front of the whole fraction. This is a negative slope, and that's what's going to happen when you have a line going down as you move left to right. In other words, the y values decrease as you move left to right. So this is a negative slope line. This one is a positive slope. When we look at our next example, the line is y equals 2, which is a horizontal line. You will notice that y is equal to 2 for all values of x. If x is a negative 5, y is 2. If x is positive 3, y is 2. So in this case, there is no rise, or the rise is 0. The y doesn't ever increase for whatever run you have in the denominator. So the slope of a horizontal line will always be 0. If we take a look at a vertical line, such as this one, x equals negative 1, that means x is always equal to negative 1. It never is anything else. So the y can be any value, but the x value is always equal to negative 1. So in this example, we can have a rise, but there is no run. The run is 0, and you cannot have a 0 in the denominator. That's undefined. So our slope for a vertical line is undefined. So understand these concepts. What does a positive slope mean? What does a negative slope mean? What does a 0 slope mean? It means it has to be a horizontal line. And what does an undefined slope mean? It has to be a vertical line. Let's take a look at parallel and perpendicular lines next. You'll have to understand parallel and perpendicular lines, and in particular how their slopes relate. So if we had L1 and L2 and they were parallel to each other, that means they never intersect. It also means the slope of one will equal the slope of the other. They have the same slopes. If you have perpendicular lines, they do intersect, and where they intersect, you will have a right angle. So I have L1 and L2, and the relationship of their slopes is the product of the slopes is equal to negative 1. So that means that 1 So that means that the slope of one will be the negative reciprocal for the other. So if we had this slope, for example, being 2, I'll call that M1, then this slope would be negative 1/2. Okay, so that's always going to be true for perpendicular lines. Let's take a look at the different forms of a linear function. I'm first going to talk about the point slope form of a straight line. Going back to our line with 2 points, instead of x2 and y2 as my ordered pair, I'm just going to have x and y. We know that slope is equal to y2 minus y1 over x2 minus x1. But in this example, I'm replacing the y2, so it'll be y minus y1. I'm replacing x2 with an x, so it'll be x minus x1. Then what I'm going to do is I'm going to multiply both sides of the equation by this denominator. So I'm just going to multiply this side of the equation by it, and it will cancel. And then I'm going to multiply this side by it. That's called point slope form of a straight line or a linear function. Here's the slope, and the x1, y1 represent the coordinates of a particular point. So this allows us to find the equation of a line if we know a point and if we know the slope of the line. So let's take a look at an example. If we were asked to find the equation of a line passing through these 2 points, I don't have the slope in this case, but I know how to find the slope. So I'm going to start with the slope. So I'll take this y value minus this y value, so 6 minus 1, over this x value minus this x value, so 4 minus 5. 6 minus 1 is positive 5, 4 minus 5 will be negative 1, so the slope is negative 5. I have a slope, and I have 2 points. I only need 1 point to find the equation. I'll do it with either point so you can see I end up with the same equation either way. But it doesn't matter, just choose one and you'll get the same equation as if you had chosen the other one. So I will choose the first point, so m, which is negative 5, times x minus, this is my x1 of 5, will equal y minus y1. And then we're going to clean this up and simplify it. So I'll distribute the negative 5. I'll add a 1 to both sides. And I like writing that in this form. So that's my equation, and we're done. Had we used the other point, so we'll just try it, m, which is negative 5, x minus 4 will equal y minus 6. Again, we'll clean this up. Add a 6 to both sides. So you can see we get the same equation. So it doesn't matter what point you choose, just pick one. Probably the form for the straight line that you'll see most often is called the slope-intercept form, and that will be obtained when you isolate the y. You'll notice that the coefficient for your x will be the slope. The constant will be the y-intercept. And the y-intercept is the y value when x is equal to 0. So that gives us quite a bit of information about the line just in that form of the equation. So if we take a look at our previous example, y equals negative 5x plus 26, this value here gives me the slope, so I know that my line has a slope of negative 5, and it has a y-intercept of 26, which means it crosses the y-axis at point 0, 26. Negative 5 slope, so it would slope down. So the line would look something like that. We can use this method to find equations of lines. So if I were to use this form to find this equation, I'm using the example that we did before, using point slope. We still have to find the slope. So I do that the way I did before, take the difference in y values over the difference in x values, and I obtained a slope of negative 5. So the first part's going to be identical. Now, however, I'm going to plug that slope and one of these points into this form to get my y-intercept. So I can choose either point. I'll use that y value. My slope is negative 5. If I'm using that y value, I have to use that x value. And now I can solve for b by adding a 25 to both sides. Once we know the slope and we know the y-intercept, we know the equation. So we get the same result. In the next video, I'm going to do more examples of finding equations of linear functions or straight lines, and with a variety of conditions. So watch the next video, and hopefully then you will be prepared to try these on your own.